Radioscope, the National Science Magazine program.
Dear listeners, welcome to National Science Magazine program Radioscope. Science is a system of knowledge about the physical, chemical, and biological universe and the things that occur in it. It is an objective observation that explains the basic rules of nature. Another approach to defining science is the information gained through practice. Listeners, in today's edition of Radioscope, we will take you through various topics, which include news highlights in the field of science and technology and famous scientists born in this month who contributed significantly to the world. So let's begin with news highlights in the field of science and technology. Space is a disabling environment, says Dr. Farhan M. Asrar, a Canadian physician and researcher of South Asian origin. When we think of space exploration, we normally perceive regular humans or able-bodied people in space suits pirouetting in the void that is our universe. Dr. Asrar has been working towards changing this perception. His research throws light on how space exploration can empower persons with disabilities on Earth. This in itself is challenging the long-held belief that space exploration is only meant for able-bodied people and is opening the doors to inclusivity. Friends, the second news highlight for you. The technology of the SSLV will be transferred to the private industry for commercial flights. The smallest launch vehicle of the Indian Space Research Organization, ISRO, SSLV, in its third developmental flight on Friday, placed the EOS-08 and SR-0 satellites into a precise 475 km circular orbit. With this, the vehicle will be inducted into the Space Agency's fleet of operational launch vehicles. The technology of the vehicle, however, will be transferred to the private industry for commercial flights in bigger numbers. With this third flight of SSLV, we can declare that the development process is completed. We are in the process of transfer of technology to industries for serial production and launches of SSLV on a commercial basis. Let's talk about our first scientist born in the month of August. Prafulla Chandra Ray was born on 2nd August 1861, known as father of chemical science. He was chemist, educationist, industrialist, and a philanthropist. Founder of India's first pharmaceutical company, Ray made several contributions to the field of organic and inorganic chemistry. Now let's move on to the second scientist born in the month of August. That's none other than M.S.Swaminathan. He was born on 7th August 1925. Known as the father of Indian Green Revolution, M.S. Swaminathan followed his vision of removing poverty and hunger from the world. During the Green Revolution, he initiated several programs under which high-yield varieties of wheat and rice seedlings were planted in the fields of poor farmers. Now, friends, let's move ahead to the third scientist. Truly an icon and a legendary, Vikram Sarabhai is widely remembered as the father of Indian space program. He pioneered nuclear power development and space research in India. Vikram Ambalal Sarabhai was born on 12th August 1919 in Ahmedabad and attended Gujarat College before moving to England to pursue his doctorate at Cambridge. Sarabhai, an institution builder by nature, founded the Physical Research Laboratory in Ahmedabad. Sarabhai's interests were diverse, and he was influential in establishing the Indian Institute of Management, Ahmedabad, in 1962, at a time when the significance of a space agency in a country's development was being questioned. Sarabhai stood up and persuaded the Indian government to establish Indian Space Research Organization. Yes, you've got it right. That is ISRO. Now, friends, let's go on to the fourth scientist born in the month of August, Gabriel Lippmann. He was born on 16th August 1845. French physicist and inventor who invented the first color photographic plate. Lippmann's major inventions revolved around Lippmann color photography, integral 3D photography, and Lippmann electrometer. He found a way of reproducing colors by photography based on interference phenomenon and was the inventor of colostat. So, friends, here we have just talked about the famous scientist born in the month of August.
Next, in Radioscope, we bring to you an interview with noted researcher of geriatrics, Dr. Ashis Chaudhuri, on tackling the physiological issues related to aging. The interviewer is Dr. Manush Pratim Das.
The science of aging is known by the name geriatrics. And there are a lot of scientists all over the world who are researching this phase of life, trying to understand why we age and whether anything could be done to reverse it. If not reverse it, at least to slow it or make that phase comfortable for the person. We have with us today Dr. Ashis Chaudhuri, Senior Staff Scientist, Bach Institute, California, a noted scientist in the field of geriatrics, who has researched the protein accumulation during old age and its bad effects on our health. We would like to know from him how this protein accumulation affects our health, how it harms our system, including the immune system, and how it pushes us towards a more sort of infirm state.
We know that accumulation of bad protein is critical for the onset of diseases like Alzheimer and Parkinson. This is a concept. People have data to demonstrate that. But people didn't have technology to understand how the protein got accumulated within cells. Usually, there is a balance between protein synthesis and protein degradation. With age, the equilibrium is shifted. Either the protein synthesis is slowed down or the protein degradation is machinery is becoming compromised. So this is the mechanism we thought it, but I experimentally demonstrate that the proteins that accumulate inside the cells during aging trigger the onset of the disease like Alzheimer. That means they basically trigger the apoptosis, the killing of the neurons, killing of the cells, which basically affect our motion, affect our short-term and long-term memory.
Dr. Chaudhuri, if we may ask, does it happen to all the animals in the world? I mean, all the creatures are affected in the same way by the degraded proteins?
That's a very good question. When I found this concept, then I was looking for short-lived and naturally long-lived animal to see whether this mechanism is pertinent with our hypothesis. And you are absolutely right. Those long-lived animals who live under harsh situation, they have the ability to get rid of the bad proteins from the cells rapidly and efficiently compared to the short-lived animals. And that's why those bad proteins, they could not get chance to accumulate inside the long-lived animal cells. Whereas in short-lived animals, they could not have the ability to get rid of their bad proteins, and those bad proteins basically triggered the death of the neurons.
Can we then logically conclude that noted scientists like you have figured out how they continue to live long, they continue to have no disease at all, sort of, yes, at least, and what are the key elements of the compounds that contribute to their well-being?
They have a very strong defense system, they have a very strong degradation machinery, they have a strong immune system, basically like bats who live 40 years under the sun, under the harsh condition, and when they carry so many viruses, bacteria, scientists found they have a very solid defense machineries as well as the immune system, and that's why those interleukins and those inflammatory response do not activate the toxic pathways to kill us.
One last question, and that is what sort of intervention are you planning to help human beings tackle aging in a more comfortable way?
I want to let you know that I discovered a novel pathway, a novel function of a molecule of hydralazine, which is used for anti-depression drug, anti-hypertension drug. So I found in 2017 that this drug possesses anti-aging property. Now I'm working with molecules called BHB, beta-hydroxybutyrate, which basically trigger the defense machineries and get rid of the bad proteins so that the neurons can be protected, can be saved.
So those words sort of instill hope in our minds that in the near future we will be able to look at aging in a different way. So thank you for speaking to us and explaining what really could be done to make aging not so feared a phase of life and how you have done this. Thank you so much.
Thank you very much.
Switching gears, let's delve into the realm of medical breakthroughs. The fight against cancer has been a defining challenge of our time. And today, we stand on the brink of a groundbreaking discovery. With the tireless efforts of two brilliant researchers, we have reached a pivotal moment where hope is no longer just a distant glimmer but a tangible reality. Welcome to this extraordinary event where science and innovation collide, bringing hope and excitement for a cancer-free world. Tonight, we present to you the findings of this novel invention of nanoparticles to arrest the human lung carcinoma cells that could revolutionize cancer prevention. We have with us Dr. Joan Jacob, Assistant Professor at the Department of Physics, Marivanius College, Trivandrum, and Mr. Jyothish B, Assistant Professor at the Department of Physics, Sri Narayana College, Varkala, to share the details of their research.
Using nanotechnology in medical diagnosis and treatment is taking the healthcare sector to higher altitudes.
In nanomedicine, scientists seek nanomaterials with much better curing effects than conventional medicines. The new nanomaterials can sometimes be mixed with the existing drug to create better results.
We could select only those materials which are non-toxic as well as biocompatible. It will not cause any side effects or should have minimum and bearable side effects. Ferrites are such materials. We know that iron is naturally existing and a non-toxic substance. Its oxides are also abundant. Nearly 90% of lung cancer is from direct or indirect use of tobacco or related products. Worldwide cancer research has brought many types of cancers to curable levels, but still lung cancer is a big challenge. In this scenario, we investigated the anti-cancer activity of various nano-sized ferrites, especially against lung cancer. We have experimentally determined the anti-cancer activities of different ferrites and surprisingly got a very outstanding result for a particular combination. In our research lab, we were preparing ferrite samples through chemical methods. Each ferrite sample was prepared by precipitation of the appropriate raw materials. The samples were well purified and were given precise thermal treatment before finalizing the product. We all know nanomaterials have unique properties because of their crystalline size at the nanometer level. We have conducted various investigations to determine our samples' size, morphology, and purity. They include X-ray diffraction and electron micrographs. We have given more importance in investigating the anti-cancer activity of these non-toxic ferrites.
Our research found that silver-doped zinc ferrite nanoparticles work effectively against human lung cancer. It controls the spread of cancer cells. Cancer cells have an abnormal property that they grow and divide at a rapid rate. Our body has a natural mechanism of destroying unwanted cells, and this mechanism is called apoptosis. Genetic engineering has identified that a human gene named P53 has a high potency to induce cell death. Cancer researchers are going in a direction to seek methods to stimulate the gene P53, hence controlling the cancer cell spread. Several researchers got good results by using metallic nanoparticles in cancer treatment.
In our study, we conducted the anti-cancer activity of silver-doped zinc ferrite nanoparticles. specifically on lung cancer tissues. We could observe that our silver-doped zinc ferrite nanoparticles could produce apoptosis by causing the breaking of the cell membrane. Nanoparticles are very small in size, hence they can penetrate through the cell membrane and accumulate within the cells, causing effective destruction of cancer cells. We have estimated the anti-cancer properties of our samples systematically and scientifically. Lethal concentration 50 or LC50 value is a standard measure of the anti-cancer activity of a medicine. It gives the amount of the drug required to kill 50% of cells within a specific period. Large LC50 means that you need a higher concentration of that medicine to cause 50% of cell death. Our studies showed that the LC50 value of our silver-doped zinc ferrite nanoparticles is 7.17 microgram per milliliter on lung cancer cells. This is a trace amount, and it was confirmed that silver-doped zinc ferrite nanoparticles can potentially destroy the lung cancer cells. We have also compared this value with that of the conventional chemotherapy medicine named 5-fluorouracil or 5-FU. This chemotherapy medicine has an LC50 value of 13.73 microgram per milliliter, which is higher than the value of our sample.
When a medicine is administered to a patient, it may kill healthy cells along with the cancer cells. So, we have conducted tests on the destructive effect of our samples on healthy cells. The LC50 value on healthy cells was determined to be 172.9 mg/ml, which is very high in concentration, nearly 25 times higher than that for cancer cells. The result is interesting since we require a deficient amount of the drug for killing lung cancer cells, which does not cause much damage to healthy cells. This is a type of targeted treatment for lung cancer.
The microscopic images showed significant morphological changes in lung cancer cells on treatment with our samples. The cells were detached, shrunken, dispersed, and cytoplasmic shrinkage occurred after treatment with the samples. Our samples can potentially restrict the migration of lung cancer cells and lessen the likelihood of metastasis.
We have conducted several other related investigations to study our samples' effect on lung cancer cells. Some are fluorescence activated cell sorting analysis, migration assay, the sample's impact on the antioxidant systems, indirect ELISA, cell cycle analysis, and finally the mRNA expression of gene P53 and gene P21 by real-time PCR analysis. All these results strengthen our silver-doped zinc ferrite nanoparticles' ability to fight lung cancer. The next step is to test it on animals and then on humans.
India is recognized globally for its scientific rigor and potential. India was able to gain pace in scientific discovery only after independence. Getting back the reins of democracy and planning the years ahead to regain our prosperity encouraged people to work towards scientific and technological advancements. In all these years, India witnessed a massive shift in different fields of science and technology by strategically aligning its skills and resources. We bring to you a quick recapitulation of the accomplishments of India in the field of science and technology post-independence and the developments we are progressing towards. The first ever 5-year plan draft was presented in July 1951, which had a dedicated chapter on scientific and industrial research. Being the first plan, it prioritized laying the foundation of scientific research in the country and largely focused on initiatives for building or enhancing national laboratories and research centers. After independence, regaining control of agriculture production was a task. Research about the crop yield potential of locations across the country, irrigation systems, effective fertilizers, pesticides, power sources, agricultural equipment was lacking. Government prioritized scientific research for advancing agriculture. This led to the Green Revolution during 1957 to 1967. This enabled India's agrarian economy, which was on the brink of collapse in 1947, to improve steadily. This revolution made us self-reliant, as we traveled the distance from being an importer of food grains to one producing it in surplus. India's contribution to the science of space is immense. The Indian Space Research Organisation, ISRO, was established in 1969 to serve as India's national space agency. The first ever Indian satellite was the Aryabhatta, which was designed and manufactured in India and was launched on the 19th April 1975. ISRO developed Aryabhatta to execute X-ray, astronomy, aeronomy and solar physics. India successfully developed strategic missile systems in the 1980s with successful testing of Agni in 1989. Eventually, Indian scientists were able to demonstrate abilities such as re-entry, maneuvering range, control, guidance, two-stage propulsion, and stage separation. Since then, India has created, tested, operationalized several missile systems. The Agni became a series of missiles, with the latest one being Agni 5. DNA fingerprinting in India came into existence in 1988 when Council of Scientific and Industrial Research, Center for Cellular and Molecular Biology scientists developed the technique and made it available for use, making India the third country to develop its own DNA fingerprinting probe. On 11th May 1998, India successfully tested 5 nuclear bombs underground in Pokhran, Rajasthan. These tests were titled Pokhran 2 in order to facilitate the technological achievement of an emerging democracy. This day was named National Technology Day by the then Prime Minister of India, Shri Atal Bihari Vajpayee. Since then, it is observed each year. Chandrayaan-1 was India's first ever mission to the moon, launched on 22nd October 2008 from Sriharikota, Andhra Pradesh. The spacecraft hovered around the moon to deliver chemical, photogeologic and mineralogical mapping to ISRO. India accounted for around 60% of the global cases of polio in 1994. A dedicated campaign to vaccinate every child by the government enabled us to become polio-free within 2 decades. India received the polio-free certification from World Health Organization (WHO) on 27th March 2014. This immunization drive was a success because of strong policy, committed healthcare professionals, frontline and community workers. A large part of this campaign was the education of those hesitant to get vaccinated in backward and rural areas of the country by increasing awareness about its safety and benefits. Mars Orbiter Mission, also known as Mangalyaan, was a historic first for India, its first ever interplanetary mission. Mangalyaan marked India's place in the field of space exploration. Launched on 5th November 2013, Mangalyaan studied Mars topography, morphology, mineralogy and atmosphere. Apart from the scientific breakthroughs, Mars Orbiter mission is also lauded for its cost effectiveness. India was at the forefront of the vaccine development research, eventually becoming one of the largest manufacturers and exporters of COVID-19 vaccines. As of end 2021, India supplied over 7 crore COVID-19 vaccine doses to more than 90 countries. Further, the scale of India's vaccination drive has been unprecedented. As we continue to evolve and innovate, The aim is to maintain the pace of development in science and technology, along with ensuring global recognition and exposure.
Let's listen to a talk on the topic, Father of Indian Green Revolution, M.S.Swaminathan, by Dr. Ravindra Bansod, Associate Dean, College of Agriculture, Kolhapur.
In the vast expanse of India's agricultural landscape, one name stands out as a beacon of change, innovation and progress, Professor Mankombo Sambeshivam Swaminathan, only known as Father of Green Revolution in India. M.S. Swaminathan has left an indelible mark on the India's agriculture history. He was born on 7th August 1925 in Kumbakonam, Tamil Nadu. M.S. Swaminathan exhibited early interest in agriculture, inspired by his father, Dr. M. Sambeshivam, who was a surgeon and an agriculturist. Swaminathan pursued his education at the prestigious Indian Agriculture Research Institute, commonly known as IARI, New Delhi. Here he earned a bachelor's degree in agriculture. His passion for advancing agricultural practices led him to Cambridge University in the United Kingdom. Here he obtained PhD in genetics. He has a lot of contributions in Green Revolution. That's why he was known as Father of Green Revolution. The Green Revolution, a period of rapid agricultural growth, owes much of its success in India to the visionary efforts of M.S. Swaminathan. In the 1960s, India faced severe food shortages, and Swaminathan, along with other scientists, worked relentlessly to develop high-yielding varieties of wheat and rice. These new varieties, combined with modern agricultural techniques, led to a significant increase in crop yields, ensuring food security for the nation. Swaminathan's role in the Green Revolution earned him international acclaim, and he became a symbol of agricultural innovation and development. M.S. Swaminathan's contributions extends beyond the Green Revolutions. He has been a champion of sustainable and eco-friendly agricultural practices. Swaminathan's emphasized the importance of integrated pest management, soil health, and water conservation also. Apart from his scientific contribution, M.S. Swaminathan has played a crucial role in shaping agricultural policies at the national and even at the international levels. Unfortunately, we lost this big figure, eminent scientist and father of Green Revolutions in September 2023 last year.
Friends, the journey through the August edition of National Science magazine, Radioscope, draws its curtains here. We hope you enjoyed it as much as we enjoyed bringing it to you. Till we meet, it's goodbye and good night from us.